another two converter that we missed yesterday. So I hope that by today we can finish on the second chapter. Maybe after this, I can give you one or two examples based on this chapter. Okay, so anyhow, okay, for today I will start with the inverter. Okay, so yesterday we have discussed about the inverter. So basically, if the converter is known as an inverter, so it just convert between the DC to AC. Okay, but when we talk about the nodes that mentioned in the nodes, so basically it refers to the inverter device. Okay, so inverter device basically refer to the system that consists of the converter and also the inverter. Okay, so converter is the conversion of AC to DC. Okay, boleh? Okay, can you see my slide now? Boleh nampak tak slide saya?
Boleh.
Okay, good. Okay, so saya start
Boleh,
dengan
boleh.
slide. Okay, so when we talk about inverter device, yes, maybe it consists of these two combination of converter. Okay, but bear in mind that when we talk about inverter only, so it just convert between DC to AC. Okay, and the converter is put in the system as a device. Okay, in order to convert, because in our normal daily life, so we use the AC source, fixed AC source. Okay, we have fixed voltage and fixed frequency, so it need to be changed first. Okay, if we want to implement the inverter. Okay, so this is the whole concept lah. AC from the TMB converter is the rectifier, inverter, and the AC machine itself. Okay, and also I have discussed this one yesterday, so you can see slightly different in terms of the speed. So this is the in terms of the speed, and also maybe in terms of the RMS voltage. Okay, so RMS voltage, both parameter frequency and voltage and frequency can affect the level of speed for the machine. Okay. Okay. Okay, so I just skip on this one. Okay, so maybe okay, so let's look at certain maybe for 5 minutes, because this video is quite long. Okay, 15 minutes. Tak apa, kita cuba tengok dahulu. Okay, can you hear the sound? The video sound? Boleh dengar tak?
Tak.
Tak dengar?
Tak dengar tu.
Okay, so saya just nak dapat feedback lah. Okay, saya tak set lagi. Okay, I just need to stop first. And I need to share including the computer sound. Okay, let's relook this video first. Okay.
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be looking at VFDs. We'll be starting from the basics to understand how they work. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. If you work in HVAC, then you need to check out the inverter compressors by Danfoss, who have kindly sponsored this video. When used in combination with variable speed technology, like the VFDs we're going to cover in today's video, they make your entire HVAC unit more efficient, saving you and your customers money. If you want to learn more, Danfoss has several e-lessons and case stories for you to check out. You can find links to those in the video description down below. VFD stands for Variable Frequency Drive, and they look something like this. You might also hear them referred to as AC drives or variable speed drives, and that's because they are used to control the rotational speed of an AC motor. We find AC motors and VFDs used in all industries, but especially HVAC. For example, we can find them used to control a compressor's speed in a refrigeration system, and that allows us to closely match the cooling demand which will result in significant energy savings. Traditionally, we would have had to use a fixed speed compressor.
Okay, so you can see from these two figures, basically also similar concept as we have in the aircon that use the inverter technology as well as non-inverter technology. Okay, on the left side kita akan set kepada desired, but on the right side this figure is just on and off. Okay, dia ada on dan off sahaja.
Now these simply just turn on and off, and that results in poor control and high inrush currents. We also find them used to control things such as pumps and fans in HVAC systems to allow us to unlock energy savings and improve performance and control. The VFD unit is connected into the motor's electrical supply. The unit can vary the frequency of the electricity being supplied to drive the motor, and by varying this we can control the rotational speed of the motor. Therefore, we have our variable frequency drive. To understand how a VFD works, we first need to understand some fundamentals of electricity. There are two types of electricity, and the first one we're going to look at is DC, or direct current. This is the simplest type, and we get this from batteries, solar panels, etc. You can think of DC like a river, with a current of water flowing in just one direction. With DC, the electrons just flow in a single direction. Now I'm animating this using electron flow, which is from the negative to the positive, but you might be used to seeing conventional current, which is from positive to negative. Electron flow is what's actually occurring. Conventional was the original theory, and it's still used widely today. Just be aware of the two theories and which one we're using. For electricity to flow, we need to complete the circuit. The electricity will then always try to get back to its source. When we use an oscilloscope to look at the electrical waveform of DC, we get this flat line at the maximum voltage in the positive region. If we cut the power, the line drops to zero. If we turn it on and off repeatedly, then we get a square wave pattern between 0 and maximum. If we pulse the switch to open and close over different lengths of time, then we would get a pulsating pattern. The other type of electricity is AC, or alternating current. This type is what you'll get from the outlets in your homes and places of work. With this type of electricity, the electrons within the copper wire constantly reverse and flow forwards, backwards, etc. You can think of this type like the tide of the sea, which flows in and out between two maximum points, the high tide and the low tide. If we follow the copper wires back to the generator, the wires are connected to some coils of wire which sit within the generator. Inside a basic generator, we find a magnet at the center which is rotating. The magnet has a north and south pole, or you can think of it as a positive and negative half. The electrons in the wire are negatively charged. And as you may already know, magnets push or pull depending on the polarity. As the magnets rotate past the coil, the positive and negative half are going to therefore push and pull the electrons within the copper coils, and these will also move them through the connected copper wires. The magnetic field of the magnet varies in intensity, and we can actually see the magnetic field lines by sprinkling some iron to move them through the connected copper.
Okay, so this is what we call when we energize the core. Okay, so once we energize the core, when the current start to flow in the winding, so this one will become magnet. Okay, this one will become magnet in the center. So we have a magnet lah. Okay, this is memang originally as a magnet. Okay, kita panggil sebagai permanent magnet. Okay, this one dia akan bergantung kepada winding. If the current flow on the winding, so it will become magnet. Okay, so this is permanent magnet.
Wires. The magnetic field of the magnet varies in intensity, and we can actually see the magnetic field lines by sprinkling some iron filings over a magnet. So, as the magnet rotates past the coil will experience a change in intensity of the magnetic field, and this will be from 0 up to its maximum intensity, and then as it passes the coil, it will decrease again back to 0. Then the negative half comes in and pulls the electrons backwards with the same change in intensity. Each full rotation of the magnet will therefore produce this wave pattern known as a sine wave. The voltage is not constant in this type of electricity. Instead, it repeatedly moves from 0 up to its peak.
Okay, sorry for that.
Moves from 0 up to its peak, then back to 0, then through the negative peak and finally back to 0 again. Frequency refers to how many times this AC sine wave repeats per second. In North America and a few other parts of the world, we find 60 Hz electricity at the outlet. Now this means that the sine wave repeats 60 times per second. And as each wave has a positive and a negative half, this means that the polarity will therefore reverse 120 times per second. In the rest of the world, we mostly find 50 Hz electricity. So the sine wave therefore repeats 50 times per second, and therefore the current reverses 100 times per second. We also have single-phase and three-phase electricity. With single-phase, we have a connection to just a single phase of the generator, so we have therefore just one sine wave. But with three-phase electricity, we have a connection to all three phases. The phases are coils of wire which are inserted into the generator 120 degrees apart from the previous. This means the coils experience the peak of the rotating magnetic field at different times. This gives us our three phases, each with a different sine wave slightly out of sync from the previous. Remember, electricity wants to get back to its source to complete a circuit. As the current is flowing forwards and backwards at different times in each of the phases, we can essentially connect the phases together and the current will move between the different phases as the polarity of each phase moves forwards and backwards at a different time. Any excess will flow in the neutral back to the source if needed, and that's only if it's unbalanced. With single phase, we have these large gaps between the peaks, but with three phase, these can be combined to fill in the gap and therefore deliver more power. In North America, you'll also find split phase systems in residential installations. Now these have two hot wires and a neutral. This is a single phase supply which is just split in half at the transformer. We've covered that in great detail previously. Do check it out, links down below. We install the VFD into the power supply of an AC motor. This is usually a three-phase supply for most applications. Now I'm going to color these phases in red, yellow and blue, simply because I think it's easier to see. But each country uses a different color code, just be aware of this. The three phases enter the VFD and connect to the rectifier. The rectifier consists of multiple diodes connected in parallel. Diodes only allow electricity to flow in one direction and block it coming back in the opposite direction. As AC flows forwards and backwards, we control the path it can take, and this gives us a rough DC output. The rough DC electricity now flows into the second part, which is the DC bus. This is the filter that uses capacitors and/or inductors to smooth out the rectified DC into a clean, smooth, constant DC voltage. It does this by releasing electrons during the gaps to smooth out the ripple. The now smooth DC then flows into the final section, which is the inverter. The inverter consists of a number of electronic switches known as IGBTs. These open and close in pairs to control the flow of electricity. By controlling the path which electricity takes and how long it flows in the different paths, we can produce AC electricity from a DC source. Let's have a look at that now in detail. We will consider the first part of the VFD, which is the rectifier. In this part, we find 6 diodes in parallel. I'll title these 1 to 6 as follows. Each of the three phases is connected to one pair of diodes. As we know, electricity needs to get back to its source to complete the circuit. So in this setup, the current will flow through the load and back to the source using another phase. Remember, it can do this because the current in each phase flows forwards and backwards at a different time. We'll see this in detail in just a moment. The load can be anything, a lamp, a motor, or an entire circuit. In this case, it will just represent the rest of our VFD circuit. The electricity will continue to alternate in the supply phases, but the diodes will only allow the peak phase to pass and will block the others. So I'm just going to animate these ones. Okay, let's see this in action. Phase 1 is first. This comes in and can only flow in one direction, which is through diode 1. It then passes through the load. Once the current passes through the load, it will then need to get back to the source. And as phase 2 is in the negative half of its cycle, the current will flow through diode 6 into phase 2. In the next segment, we see the current is still flowing in phase 1 and diode 1. But now phase 3 is in its negative half. So the current switches and the flow returns through this phase via diode 2. In the next segment, phase 2 is approaching its peak. So the current now flows through this phase and through diode 3. It then flows through the load and back into phase 3 via diode 2. In the next segment, the current flows still in phase 2 via diode 3, but phase 1 is now at its negative peak, so the current will flow through diode 4 back into phase 1. In the next segment, we see that phase 3 is now approaching its positive peak, so the current flows through this phase via diode 5. It then flows through the load and then returns via diode 4 into phase 1. Finally, the current flows through phase 3 via diode 5, through the load and then back into phase 2 via diode 6. This cycle just repeats constantly like this. The oscilloscope for the three-phase supply will see 3 sine waves for the AC electricity. But the oscilloscope on the load will see this as a rough DC electricity with some ripples in it. Now we need to smooth out those ripples to clean up the DC electricity. For this, we connect a capacitor across the positive and the negative. This capacitor is like a storage tank and will absorb electrons when there is excess, and it will inject electrons when there is a reduction. This will therefore smooth out the ripples in the DC electricity to a nice smooth signal on the oscilloscope. We have covered capacitors in great detail previously. Do check that video out, links down below. Now that we have clean DC, we're ready to turn that back into precisely controlled AC at variable frequency. And for that, we need an inverter. An inverter is basically a number of IGBTs, which are switches that can turn on and off super fast. I'm going to animate this using some simple switches instead of IGBTs, just to make it easier to visualize. I'll number these switches as follows. To get our 3 phases, we need to open and close switches in pairs to direct the flow of current from a supply and a return pass. That way, the connected motor will experience alternating current. Remember, AC is where the current reverses. So if we took a lamp and connected it to some switches and a DC power source, we can control the directional current through the lamp by opening and closing switches in the right order. Therefore, the lamp experiences alternating current even though it's coming from a DC supply. For the 3-phase supply, we time the switches to simulate the 3 phases. Let's see how this works. First of all, we close switches 1 and 6. This will give us phase 1 to phase 2. Then we close switches 1 and 2. This will give us phase 1 to phase 3. Then we close switches 3 and 2. This will give us phase 2 and phase 3. Then we close switches 3 and 4. That will give us phase 2 and 1. Then we close switches 5 and 4, and this will give us phase 3 and phase 1. And finally, we close switches 5 and 6, and this will give us phase 3 and phase 2. This cycle repeats again and again like so. If we check this with the oscilloscope, we now have a pattern that looks like AC sine wave, although it's just a little bit square. This will work fine for some applications, but not all. So how can we improve this? Do you remember earlier in the video, I said we can open and close the switch at different speeds and durations to change the waveform? Well, we can do that with this too. What we do is use a controller to rapidly open and close the switches multiple times per cycle in a pulsating pattern, each pulse varying in width. This is known as pulse width modulation. The cycle is broken up into multiple smaller segments. Each segment has a total amount of current that could flow. But by rapidly pulsating the switches, we control the amount of flow occurring per segment. This will result in an average current per segment, and we can see that this increases and decreases, thus giving us a wave pattern. The load therefore experiences a sine wave. The more segments we have, the closer it will mimic a sine wave. We can control the output voltage by controlling how long the switches are closed for. So we could, for example, output 240 volts or 120 volts just by trimming the opening and closing times. We can control the frequency by controlling the timing of the switches. So we could, for example, output 60 Hz, 50 Hz or 30 Hz, whatever is needed for the application. Remember, by controlling the frequency, we control the rotational speed of the motor. So coming back to our VFD circuit, we're going to use the controller to rapidly open and close the switches to vary the output frequency and voltage. So by combining the rectifier, the filter, and the inverter, we therefore get our variable frequency drive. And this is what is used to control the speed of the electrical motors and unlock energy savings in all sorts of systems. Okay guys, that's it for this video, but to continue your learning, then check out one of the videos on screen now and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, Instagram, LinkedIn, as well as the engineeringmindset.com.
Okay, so you understand whatever the thing that explained in the video. Boleh faham tak? Hello?
Boleh faham je.
Okay, so that's the thing, because again, because in the video they just focus on the parameter. They explain about the frequency and the voltage can affect the speed of the levels of the speed for the machine. But later we will take a look in terms of the equation, because the equation we can use the equation. We can check. Okay, the equation is based on depending on what kind of parameter. So basically on the speed part, kita akan ada equation yang bergantung terus kepada frequency as well as the voltage level. Okay, so that's why the explanation of the video is focusing on to change the voltage as well as to change the frequency. Okay, so I think from the video it also explain, because kita memang ada basic kepada AC voltage. Residential memang kita pakai AC. So that's why when we talk about the VFD, so VFD is a device. Okay, kita panggil sebagai inverter device that consists of the rectifier as well as the inverter. Okay, so VFD ni memang the whole setup lah, kita ada dua-dua. But when we talk about inverter, macam saya cakap tadi lah, inverter device is just DC to AC. Okay, so dia dah explain kepada kamu. We have also some explanation on the speed. Okay, macam mana kita nampak the stator is induced. Okay, masa bila kita nak jadikan dia positive, north or south, depending on the current flow. But the detail we cover on the third and fourth chapter lah, bila kita masuk kepada machine. Okay, when we talk about machine, so saya akan tunjuk satu lagi video untuk your understanding lah. So you will see how the magnetic interact between the stator and the rotor part, so that we can have the rotation. So tadi pun dia ada tunjuk sedikit the concept of magnet. Kalau kita ada two different pole, so kita akan ada dia menarik, dia attract. Okay, tapi kalau dia ada two similar poles, dia akan repel, dia akan menolak. Okay, so dekat situ that's the concept of having the rotation of the machine. Okay, tapi in detail kita akan tengok waktu kita belajar machine. So anyhow, for this part saya just nak cover on the converter sahaja. So this is what the video explain lah. So we have an AC, and then kita ada DC just after we pass through the rectifier. Okay, dia ada two time filter lah. So satu filter yang kita ada, the first one is DC filter, DC link ataupun DC bus. Okay, the second one, okay, basically this inverter, okay, if we take a look at the video, at the first place, basically the voltage, if we don't have the PWM, will look like a square waveform. Okay, kita nampak petak-petak sebab dia on dan off sahaja. Okay, but anyhow, because we implement the PWM, so kita menggunakan kaedah switching. So there are some portion of switching yang kecil, so maksudnya dia on sekejap, and then dia akan ada yang agak wide, so dia akan on lama. So bila on lama, value dia akan jadi tinggi. So that's why you can see that finally the output of the inverter will be like a pure sine wave. So they also mention kalau kita ambil lagi banyak switching, sebenarnya we are moving close to a pure sine wave signal. Okay, so lagi banyak, lagi laju kita switch, so sebenarnya lagi cantik kita punya sine wave. Instead of kalau kita ada frekuensi yang slow ataupun kita ada PWM yang slow. But also the video mention there are certain equipment. Okay, there are certain equipment that can straight away use the square AC waveform, memang ada. Okay, but for motor sebenarnya tak boleh lah. Okay, motor tak boleh sebab kita kena ada kekuatan of the magnet. Okay, tadi kamu tengok ada waktu dia peak maximum, and then kita ada kosong, and then kita ada peak pada minimum. So peak pada negatif, peak pada positif, and kita ada kosong. So we call it the strength of the winding, the strength of the magnetic depending on the current. Okay, kalau dia peak lah, dia kuat lah. and then dia kalau dia negative peak, so dia akan menolak, dia akan menukar daripada north kepada south. So anyhow, because saya just nak fokus on inverter, so this is the thing, AC to DC and then DC to AC. Okay, kalau kita tengok ni, we cannot say this is a inverter sahajalah, this is the VFD. Okay, sebab combination ataupun kita boleh panggil sebagai inverter device. Okay, so this is inverter device lah. Okay, so kita ada smoothing and then kita ada switching, so that use the signal from the PWM. Okay, ini semalam saya explain. Okay, so saya start dengan this one lah. Okay, so dekat sini kita ada pure AC. Doesn't matter whether we have 220. Okay, basically you learn the basic concept. Single phase is 240. Okay, but in reality basically it may be between 230 to 240. Okay, dia sama lah, 230, 240. But US I think is 110. Okay, so this is AC, dia akan masuk lah, okay, kepada kita punya rectifier. So there are some protection devices here. Okay, so dia akan masuk. So after pass through the rectifier, so you can see that this is changed. Okay, instead of kita ada positive and negative cycle, so now we only have positive cycle. But this is not a straight line, okay, because in our imagination DC must be a straight line. So we have to filter it. Okay, we have several stages of DC bus. So dalam kes ni kita ada mungkin 4 ni, and then dia akan jadikan benda ni sebagai continuous. Again dalam video tu pun dia bagi tahu, okay, once kita ada switching yang on, so dia akan store the energy inside the capacitor. But once dia jadi kosong, so dekat sini dia jadi kosong, dia akan discharge lah. Okay, dia akan discharge supaya kita maintainkan dia punya energy. Okay, so dalam kes ni lagi besar kita punya size capacitor, sebenarnya lagi smooth kita punya signal. So we assume that just after the DC bus, so the DC voltage is quite a straight line lah. So dekat sini, okay, and then what happen is we will pass through the power transistor. Okay, so power transistor ni, ini adalah kita punya inverter lah. Okay, so this is by using the transistor. So we assume that we have this PWM signal. So kalau kita tengok, if you can zoom, focus on this PWM, kita ada yang agak thin and then kita ada yang agak white, yang tebal ni lah. So this represent the value of the current yang flow. Okay, the magnitude of the current. So lagi kecil and then lagi pendek lah. So kalau lagi lebar, so lagi besar lah dia punya value. So the magnitude. So you can see that kalau yang kecil dia di bawah lah, and then kita akan tebal di tengah, because this is the maximum point. And then kita akan pergi ke kosong, and then kita ada PWM yang negatif. So this is the signal for the switching to convert to the AC. So the faster the frequency that you have, basically the more pure sine wave yang kamu akan obtain. Okay. So function of converter. So in this slide, so basically they just explain back the concept of rectifier, but the other names for the rectifier that combine with the inverter device we call as a converter. Okay, so it just changed from AC to DC. Okay, so you can see that they just potong lah. Okay, they flip the negative cycle naik ke atas, and then they just move the signal. Okay, boleh faham? Boleh faham ke tak boleh faham?
Yes,
okay, good. So, okay, saya move kepada next slide. Okay, function of converter. Okay, this is also the same as what I just explained to you. Okay, so the stages start from the rectifier. So this is the AC. So this one dia akan masuk kepada bridge. So this is the capacitor link, and then this is the one, okay, untuk kita dapatkan kita punya switching lah. So dalam case ni kita nak hidupkan kita punya controller. Okay, so kita ambil voltage di sini. Okay, kita ada step down transformer, and then kita akan ubah lah. Okay, so this is for stepping motor. Okay, 13 volt DC. Okay, before pass through the inverter and finally connected to the DC AC motor. Okay, so this is a function of converter lah. Boleh? Boleh? Okay. Kalau tak ada apa-apa, so kita akan move pada next slide lah. So this is for inverter. Okay, just after we get the pure DC signal, straight line, so it will change back to AC, but now with different, maybe we can change the different frequency as well as the voltage magnitude. Okay, so by looking at this system, okay, kita ada sepatutnya 6 switch lah. Okay, because when we talk about AC, basically we are focusing on 3-phase AC machine. So we need to generate for 3-phase AC source lah. Okay, so we need to put a combination of 3 pair, maksudnya 6 unit of the switching. Okay, sebab kita akan generate 3 phase, but every time that we generate, so the current must be from source kepada return balik kepada source. So macam tadi dia beritahu, each time switching akan on, dia akan on 2 lah dalam bentuk pair. So dia akan pergi daripada source and then return balik kepada source juga. Okay, so that's the thing. So kamu dah tengok tadi the video. So how we can generate the AC signal. Okay. So by signal being input on each transistor, current will go through the motor. So this signal input format is different according to the motor. Okay, kita punya ni pun bergantung kepada motor lah. Okay, so kita ada AC inverter and DC inverter. Okay, so inverter part consists of more than one pair lah. Okay, so sama ada single phase ataupun 3 phase. Okay, dia ada dua-dua lah. Okay, IPM is the Intelligent Power Module. Okay, kita panggil sebagai IPM lah. So this is when we want to generate the PWM. Okay, so transistor pun boleh pakai lah. Sama je transistor or MOSFET, semua kita boleh pakai. As long as the switching can be, we can send the signal for the switching to turn on and as well as turn off. So kita boleh pakai. Okay, transistor kita tak boleh pakai sebab kita hanya boleh kawal on sahaja. Okay, so this is the basic lah. Kita boleh pakai MOSFET, boleh pakai IGBT. Okay, so macam saya cakap tadi lah, every time that we turn on the switch, it must be in pair. So dia akan pergi daripada source dan dia must return balik kepada source. So dalam case ni kita akan ada flow di sini. Okay, and then the next one kita akan flow based on the sequence lah. Okay, based on the sequence, whatever the thing yang kamu tengok dalam video tu, itu adalah the sequence to generate the 3-phase AC source. Okay, so dia mesti dalam bentuk pasangan pair. Okay, pergi and return balik kepada source. Okay, so this is PWM inverter lah. Okay, so kita ada equation sebenarnya, V out sama juga dengan VD. Okay, or multiply by T on over T on plus T off. Okay, I think you might have seen this equation before. Pernah tengok tak equation ni? V out is equal to VD. Okay, multiply by T on over T on plus T off. Pernah tengok?
ETO saya lepas.
Ada, okay. So you must familiar lah already on the equation. Okay, sebab for this subject, okay, I'm not going to implement this equation again because we are just focusing on the output of the converter. Okay, final equation to get the output from the converter. But hopefully you can still remember this equation. Okay. So let's look at this analog signal. So dekat sini kita ada between 0 to 5 volt. So we can say that, okay, so if we have a 0 duty cycle, so duty maksudnya bekerja, so kalau kosong maksudnya tak bekerja langsung. So this is how we write in the coding, but at the end ini sebenarnya akan menghasilkan kosong volt lah. Okay, kosong, memang tak adalah kosong. Okay, and then kita ada 25, so mungkin dengan 25 tu kita ada satu level of voltage yang dihasilkan lah. And then kita ada 50%, okay, so 50% means that 50% daripada switching time adalah bekerja on high atau dan juga 50% lagi adalah low. So percentage of this represent the on time. Okay, 25% duty cycle means that 25% is on, another 75% remaining is off. So 50 is samalah balance, on dan off. 75% duty cycle must be 75% on and 25% off. So 100% means that the switching is always on for the time duration of the cycle. Okay, T. Okay. So can you see this one? Boleh nampak tak yang bawah ni? Boleh nampak tak?
Yes, sir.
Okay, the red one ni sebenarnya apa? Yang merah ni. Okay, yang merah ni apa? Okay, yang merah ni adalah the carrier signal. Okay, dekat sini dia dah tulis lah. This is the carrier signal ataupun kita panggil sebagai sawtooth signal. Okay, berbentuk sawtooth lah. And then kita ada juga yang belakang ni kita ada warna hitam. So this one adalah modulating signal. So yang ni lah. Okay, how to generate the PWM? Basically, we need to compare between these two. Okay, so in this case, we do the we put the both signal dalam gate comparator. We need to do the comparison. At the end, we will generate the PWM. But can you explain to me how can we do the comparison between the carrier signal as well as the modulating signal and finally get the PWM? So cuba tengok daripada gambar ni. So macam mana PWM ni diwujudkan?
Buat garis putus-putus.
Okey, buat garis putus-putus. Di mana? Di mana kita nak buat garis putus?
Dekat intersection.
Intersection point between the carrier dan juga modulating. Okay, good. Okay, cuba kita tengok yang positif ni dulu. So what can you observe? Okay, when we do the comparison between the sawtooth dan juga modulating. Dekat sini, apa yang kamu boleh nampak yang mewujudkan this PWM?
Dia ke atas.
Dia ke atas. Apa maksud dia ke atas tu?
Positif cycle.
Positive cycle, okay. So when it is positive cycle for the modulating signal, so apa yang akan menyebabkan kita dapat PWM on? Itu soalan saya. Macam mana kita boleh tahu, okay, this PWM must be turn on under this condition? Apa yang kita buat? Apa yang kita compare tu sebenarnya? Okay, so kita akan compare sebenarnya value of, okay, kita tengok dekat sini. If I can zoom in, saya cuba zoom in. Okay, can you see now? Okay, so kalau kamu boleh nampak dekat sini, we do the comparison between the modulating dan juga kita punya carrier signal, kita punya sawtooth signal. Okay, so just now your friend said that we need to do a dotted line at the intersection point. So bolehlah kita tarik semua. Intersection means that yang cross lah, sawtooth ni yang cross dengan kita punya modulating. Okay, so saya ambil satulah dekat sini. Okay, so macam mana kita boleh dapat this PWM signal adalah berdasarkan kepada comparison between sawtooth dan modulating. Okay, every time that the modulating is higher than the carrier signal, it will on. So on ni kalau kamu tengok waktu sini, sini dan juga sini. Sebab apa? Sebab waktu sini ke sini, so the sawtooth ataupun the carrier signal is less than the modulating signal. So sepanjang-panjang inilah dia on. But once dia ada naik, so maksudnya sawtooth melebihi daripada kita punya modulating, so dia akan off. Okay, so kita tengok off dia pendek je lah sebab this is the intersection point. Ada 2 point di sini. And then again dia akan return balik kepada the next intersection point dari sini ke sini. So at this moment of time the carrier signal is less than the modulating signal. So less maksudnya dia akan on. Okay, so dia akan continue. So now kita pergi dekat negative. Okay, so now we move to the negative. Same concept. So dalam case ni, okay, di sini negative. So this is the carrier signal. So carrier signal is more than the modulating signal. So this one akan jadi off. Okay, modulating signal adalah lebih tinggi daripada carrier signal di sini. So dia akan on. Okay, and then this one modulating signal is less than the carrier signal. So dia akan off. Okay, this one sebab dia ada ke bawah sikit ni, so dia ada portion sedikit modulating signal is higher than the kita punya PWM signal, kita punya carrier signal, so dia akan on. So boleh nampak tak dekat sini? Boleh nampak tak?
Yes, sir.
Okay, good. So now kita boleh nampak lah. So dari laju kita punya kita pecahkan kita punya modulating signal untuk dihantar kepada switching, so kita akan dapat lagi banyak kecil-kecil point. Okay, so your PWM will look closer, dia jadi macam satu yang rapat sangat. Okay, so dia jadi macam betul-betul square ataupun berbentuk box, kotak lah. But when we zoom in, kita akan nampak dia sebenarnya adalah berbentuk macam ni lah. Dia ada yang lebar sikit and then dia ada yang kurus sikit. So this signal will be sent to the modulating signal. Kalau kita tengok, dia ada PWM lah. So this is PWM. So dia akan hantar kepada switching. Okay, so this PWM. So PWM dia hantar kepada switching. So switching ni dia akan ikut signal. So high dia adalah on dan low dia akan off. So in this case, macam sama juga dia cakap tadi. Okay, the faster the frequency that you have for your PWM, the closer the signal of the output will look like a sine wave. Okay, so dia akan jadi lebih kepada sine wave. Okay, so ada soalan. So saya dah habiskan kepada inverter. Okay, so ada apa-apa soalan untuk inverter before we move to the last converter? Ada soalan tak? Okay.
Tak ada soalan pun, sir.
Tak ada soalan. Okay, before this, can I know whether you have tried any simulation that can generate the AC sine wave? Pernah guna tak apa-apa simulation software yang kamu boleh generate daripada DC kepada AC? Have you use any software before? Okay, last time you mentioned to me that you have learned the power E and also you have some exposure on using the PSIM software. Pernah ke saya salah?
Tu AC ke DC?
AC ke DC sahaja. So DC ke AC tak pernah buat?
Tak kot.
Okay.
Buat manual je.
Okay, buat manual sahaja. Okay, because when we talk about AC, in that video also they mention because the peak of each phase adalah berbeza. Okay, antara red, yellow dan blue adalah berbeza. So tadi dia bagi tahu kita ada phase shift lah. Kita ada beza angle between the maximum of red, yellow and blue. So dekat situ sebenarnya kamu kena lebih aware how to switch the switching. Macam mana kita nak bagi signal kepada switching sebab kita ada beza angle 120 darjah each phase. Okay, tak apa, nanti kalau saya ada berkesempatan insyaAllah saya akan cuba tunjuklah on the PSIM software. Okay, so PSIM software ni is a powerful tools lah for me to to explain to student. Okay, and now we move to the last converter. So this is what we call as the AC voltage controller. Okay, AC voltage controller is a device when we want to change directly from AC to AC. Okay, the AC to AC. So the power flow into a load can be controlled by varying the RMS value of the load voltage. Okay, RMS adalah effective value. So effective value sebenarnya adalah keluasan di bawah graf. Okay, keluasan dari bawah graf. So if we have a full area of the curve, so kita akan cakap dia sebenarnya sama dengan source voltage. But if we just switch late, maksudnya kita buat slightly delay on the alpha, so kita akan nampak the area is less. So the area basically reflect the value of RMS voltage. So point number 2, this can be accomplished by thyristor, and this type of power circuit is known as AC voltage controller. So dia dikenali sebagai AC voltage controller. So you can see that by using this system, we can straight away put the AC fixed voltage from at the input side, and then we straight away can change the output of the converter by having a variable either voltage as well as the frequency. Okay, as well as the frequency. Dua-dua boleh. Okay. Okay, this is what I mentioned about when we slightly delay on the switching. Okay, so this is the firing potential. So kita akan tengoklah. Okay, so bila kita trigger lambat, so dia lambat lah. So lagi lambat kita trigger, so sebenarnya keluasan yang atas ni, okay, this is VAK. Sorry for that, this is VAK. VAK maksudnya dia adalah switching. Okay, AK ni maksudnya kita punya voltage dekat kita punya thyristor. Okay, nanti saya akan cuba bagi comparison between 3 signal lah. Kita tengok dekat sini nanti. Okay, kita ada, let's say, I just want to check first. VAK. Okay, VAB tak ada. Okay, tak ada. Okay, so VAK. So apa yang kamu akan nampak dekat VAK ni? So this is firing potential. So bila kita fire, okay, so apa yang kita nampak sebenarnya? So what can you see from this animation? Boleh tak someone explain to me apa yang kamu faham? Apa yang kamu faham daripada this one?
Tak faham saya, tak faham apa-apa.
Tak faham apa-apa. Okay, so kalau kita tengok, we need to know the potential. Okay, dalam kes ni dia cuba tunjukkan firing potential. So there are some kita panggil sebagai minimum value. Okay, so bila kita nak trigger the switching, kita kena make sure that it is at least at the minimum value of the firing potential. So kalau kita tengok dekat sini, kita punya firing potential adalah straight line yang warna merah ni. Okay, once we want to trigger, okay, if the signal is more than the firing potential, so dia akan ada switching tu terus kita on lah. So dekat sini dia on pada point tu. Okay, so dia akan on pada point tu. So tetapi bila kita punya firing potential, kita punya signal is less than the firing potential, so they say here trigger wave amplitude too low. Maksudnya switching kamu langsung tidak on. Okay, langsung tidak on lah. Okay, nanti saya akan kita cuba tengok satu simulation. Okay, for me better saya tunjuk sekejap. 10.54. Okay. Okay, I just want to show you apa sebenarnya VAK lah. Okay, I just share my PC sekejap. Give me 1 minute. Sekejap. Okay, I need to find first the file. Sekejap ya. Let me find first. Okay. Boleh nampak tak saya punya PEE software ni?
Boleh sir.
Okay. So boleh saya tanya kamu tak? Okay, what kind of AC regulator that I have just now? This one. Kita panggil sebagai apa ni? Okay, so I have a combination of two switches. Okay, one I'm using the thyristor and another one I'm using diode. So what kind of AC regulator yang saya ada dekat sini? This one. Kita panggil sebagai
Uni.
uni. Okay, good. Very good. Okay, kita pakai uni. Uni apa?
Unidirectional AC voltage controller.
Okay, good. Very good. This is uni. Kenapa uni sebenarnya? Apa maksud behind uni tu? Okay, very good.
Satu laluan.
Satu laluan. Satu laluan. Adakah yang dekat diode ni dia tak lalu?
Jadi negatif.
Okay, positive because we now change from AC kepada another AC. So saya letak sini AC source. Okay, let's we look at the simulation. So apa yang saya akan dapat? So saya ada V in and then saya tambahkan dengan V out. Okay, saya dapat dekat sini. Okay, so apa maksud uni tu sebenarnya? Saya masih ada output pada positif dan saya masih ada output pada negatif. So what do you understand about the word uni tu tadi kamu beritahu saya? Okay, so from this simulation I just want to highlight here by controlling the device of the switching devices, we can get the different value of RMS voltage. So dekat sini saya klik saja RMS. So V in saya RMS dia adalah 240, but V out saya RMS dia hanyalah 228. So this is one of the technique lah. Okay. Tapi saya masih lagi nak tanya kamu. So what do you understand by the means of uni tadi? Satu laluan, kita masih ada lagi dua output.
Entah, saya pun tak tahu.
Okay, uni means that we only control the switch at one position only. Kita kawal satu je. So satu lagi kita biarkan diode. So kalau kamu tengok dekat sini, pengawalan hanya pada the tharistor sahaja. Okay, satu lagi saya tak letak diode. So if you can see from the waveform, dekat bahagian tharistor positif. So maksudnya waktu dia positif, dia akan masuk ke sini lah. So positif is here, dia pergi sini. So kita kawal dia. So this is what we call as a uni. Okay. So once kita ada negative cycle, so dia akan patah balik. So dia melalui diode. So diode dia akan terus on. Okay, waktu dia forward bias. Negatif dia akan forward bias lah. Okay, dalam case ni kalau kamu tengok negatif, terus kita ada output. Okay, this is what we call as a uni. Pengawalan hanya pada satu switch saja. Okay, but if we have bi-directional, so kita akan ada pengawalan pada kedua-dua switch. Okay, so voltage kita boleh varies lebih banyak lah compare dengan this one. Okay, VAK yang saya nak tunjuk sebenarnya adalah pada cathode. Okay, kalau kita tengok VAK tu sebenarnya adalah pada kita punya tharistor tu sebenarnya. Okay, so let's me put one switches dekat sini. Okay, ini adalah VAK. Okay. So apa yang kamu nampak dekat VAK? Apa yang kamu boleh faham daripada gambar VAK bawah ni? This one.
VAK tu voltage dekat tharistor je.
Okay. So apa yang kamu boleh observe? Kenapa waveform tu ada sebelum and then bila dia dah ada output dia tak ada?
Macam saya cakap semalam tu kot.
Okay. Semalam saya cakap apa?
Potential difference.
Okay,
Yeah.
Okay, good. Potential. Because this is a switching. So bila kita tengok switching, okay, so kita kena make sure yang switching tu, bila switching, so potential between yang dua point tu adalah sama. So if we find the voltage across the switching, so basically dia mesti sama dengan kosong. So once kita off ataupun kita close, kita bagi signal kepada tharistor, so dia akan close. So bila close, potential dia sama. Okay, negatif tak adalah because I just focus on VAK. Okay, so dia hanya ada di sini. Okay, so tadi kalau kita tengok, okay, from our understanding, so tharistor ni dia hanya akan on daripada 0 kepada 180 sebab kita punya cycle adalah positif pada 0 hingga 180 sahaja. Okay, so bila saya nak trigger this one lebih daripada, saya trigger sebagai contoh, saya trigger this one 180 81. Okay. So apa yang kamu boleh nampak dekat sini bila saya trigger kepada 180? Apa yang kamu boleh predict ataupun observe daripada waveform ni? V in, V out dan VAK.
So,
Macam mana? Okay, VA tak ada masalah, is similar macam yang sebelum ni. So it's just positif 20, negatif 240. Okay, tetapi V out dekat sini kosong and then VAK ada. Okay, so apa interpretation kamu kepada gambar ni?
Bila trigger pada 180, switch tu baru on dekat 180 tu. So dekat negative cycle baru dia on macam tu.
Cycle. Adakah kamu memberitahu saya this one daripada switching of the thyristor?
Apa sah? Again.
Adakah kamu beritahu saya waktu kita dapat V out ni dekat negatif ni, ini datang daripada switching of the
Diode.
okay, ini daripada diode.
Yes.
So kalau kamu beritahu tadi selepas 180 baru thyristor akan switch on. Betul? So apa jadi pada thyristor tu sebenarnya? Pada this point.
Tak tahu sah.
Okay.
Dia tak on ke?
Sebenarnya dia tak on langsung. Good. Dia tak boleh on langsung because dia sama macam diode, dia must be in forward bias and we need to give the injected signal. Okay. Tapi dalam kes saya ni saya just bagi dia pada 180. So pada 180 this is the starting point that they interchange between the forward bias and negative reverse bias. So we assume that at this moment of time dia tak ada apa-apa switching. So walaupun kita hantar signal tu 180 dia macam dalam keadaan bandai lah. Tapi bila kita bagi tahu signal, okay, you must turn on, the thyristor must turn on at 180, so dia dah tak boleh dah. Because just after 180 kita akan wujud negative cycle. So dia dah tak fulfill the requirement lah. It must be forward bias sebab direction of the diode dia pointing to the right. Dia macam untuk positif saja. So that's why waktu dekat sini langsung tak ada output. So this one sebenarnya datang daripada diode. VAK is always available because dalam kes VAK, so sebab kita ada two different potential. So VAK ni kalau kita tengok sama tak dengan input? Sama atau tak sama? Bentuk dia lah.
Sama.
Sama. Okay, ataupun kalau nak tunjukkan, okay, kita pergi dekat maximum point. Okay, so maximum point, this is V in, this is V out. Sama tak dua-dua value ni? Sama, betul? Kan, sama kan? Okay, VAK dengan ni. Sebab apa sama? Sebab apa VAK ni sama dengan V source apabila switching kita off. Can someone explain to me? Kenapa VAK adalah sama dengan Vsource apabila switching itu off? Okay, so jawapannya adalah when the switches is off, the current cannot flow at all. So basically bila current tak flow at all, so elemen ni semua jadi macam shorted. Okay, sebab tak ada voltage drop di sini, current tak ada. Apa yang dibaca must be exactly the same as the source voltage. Sebab potential dia sini straight ke sini, sini pun straight ke bawah. Okay, so this is just the meter lah, ni tak payah kisah, this is meter, tak ada issue. Tapi yang saya nak maksudkan di bahagian load di sini semua di bypass sebab there are no voltage drop at all. Current tak flow sebab switching adalah open. So yang kita baca sebenarnya sama dengan Vsource. Okay, anyhow saya kena masuk juga dekat sini. Okay, this is the explanation lah. Okay, waktu kita nak trigger tu. Okay, waktu kita nak trigger. So, okay, once kita trigger, dia nak tunjukkan dekat sini, kita trigger, V akan jadi kosong. Okay, V akan jadi kosong lah. Okay, once kita trigger dia, dia akan jadi kosong. Kat mana-mana kita trigger tu lah. Okay. Okay, so dekat sini kita trigger lah. Okay. So ini adalah kita punya output voltage. So tadi kita dah tengok dah, lagi lewat kita punya alpha. So sebenarnya lagi kecil kita punya effective area under the curve. So dia akan reflect kepada RMS value. Again, RMS adalah the effective value of the area under the curve. Okay, lagi lambat. Tadi saya buat pada 180 memang tak ada output langsung. Okay. So type of voltage controller kita ada classification between the single phase and three phase. Yes, kita ada dua-dua. And then kita ada unidirectional and kita ada bidirectional. So unidirectional ataupun half wave AC controller kita mengawal separuh sahaja. Okay, bidirectional kita mengawal kedua-dua switching. Okay, so in brief, different type of AC voltage controller are single phase, half wave. Single phase maksudnya kita ada satu yang pengawalan dia pada satu saja. Okay, and then kita ada single phase, and then kita ada dua. So pengawalan atas dan bawah. And then kita ada combination lah. Okay, 3 phase, half wave, and then kita ada 3 phase, full wave. Okay, whatever the thing, kalau uni maksudnya, because this is AC, okay, kita akan ada positive dan negative cycles. So when we talk about uni, one of the cycle we control, itu sahaja. Okay, another cycle kita tak boleh kawal, so kita hanya letak diode. Bi kita kawal kedua-dua. Okay. So, okay, kita ada dua teknik lah. Okay, do you familiar with this technique? On-off control dan juga phase angle control. Pernah dengar tak dua-dua ni? On dan off.
Yes.
Okay, pernah ingat lagi dah?
Pernah.
Okay kan, dah belajar dah. Semua kamu calculation semua dah buat lah. Okay, so in on-off control, thyristor switches connect the load to the AC source for a few cycles. So ada a few cycles dia sambungkan dengan load and the input voltage and then disconnected for a few cycles. Dia main macam cycles lah. Okay, on dan off. Okay, so in phase control pula, thyristor switches connect the load to the AC source for a portion of its cycle. Kita ada portion lah. So dia bergantung kepada alpha. So kita boleh kawal lah sama ada kita ada on dan off, lebih kepada macam PWM. Okay, as long as kita dapat area under the curve, doesn't matter kalau berbentuk PWM ataupun dalam bentuk portion. So kita akan consider the area under the curve. Itu yang kita jadikan sebagai the effective area yang masuk kepada mesin. Okay. And then kita ada this one, okay, the principle of on-off control. So kita ada principle yang ni lah, okay, on dan off. Okay, ada portion untuk kita punya pengawalan. So dalam kes ni kita nampak kita ada bidirectional. Okay, this is single phase. Okay, so this is power factor. Okay, power factor dia kalau kita tengok dia akan moving towards the unity. So later kita akan tengok lah, sebab bila power kita bagi banyak, output kita dapat sikit, so sebenarnya kita the less power factor. Tapi kalau kita move kepada voltage yang besar, so power factor akan jadi close to unity. So VM adalah kita punya this is VS, this is Vout, this is gate signal lah. Okay, so kita boleh nampak kita menggunakan portion N dan M. Ingat lagi tak N dan M? Ingat lagi tak macam mana kita nak baca signal ni, waveform ni? Apa yang kamu boleh predict kat sini? N dan M.
Buka tutup.
Buka dan tutup.
On off.
Okay, yang mana satu buka, yang mana satu tutup?
N on, M off code. Lupa.
Lupa dah? Okay.
Lupa.
Okay, cuba kita tengoklah. Okay, basically you can see by this gate. Okay, bila kamu inject, okay, so kamu ada output. Okay, so cuba tengok dekat sini kita ada gate 1 untuk T1 lah, gate 2 untuk T2. So bila kita inject gate 1, okay, so dia ada positif lah, kan, current akan start to flow. This is V, VM, and then kita ada I slightly kecil lah. Okay, kita on dekat sini. Okay, so bila masuk negatif, kita inject juga benda ni. So kita inject dia, so dia akan ada output lah. Okay, maksudnya on dan off pada cycle ni, so kita ambil on dan off dia. So dia ada complete lah. So bila kita ada positif balik, kita inject balik T1 pada kosong angle. So kita nampak dia macam follow lah yang atas ni. Okay, and then kita ada off di sini, on di sini untuk negative cycle, which is from the T2. And then kita off kan dia. So dekat sini, this is the portion of off. So there are no signal dekat sini. Okay, so there are no signal, so output pun tak ada lah. Okay, and then kita cuba on balik. So on balik, kita hantar signal di sini, so dia akan on lah. Okay, kita akan dapat balik. So this is a portion of on dan off yang kamu dah belajar lah. Okay, on dan off. So maksudnya ada portion. Okay, portion dia dalam satu, sebab this is quite fast. Macam that video mention to you, okay, for 50 Hz frequency, so dalam satu minit, dalam satu saat, okay, kita ada 100 signal lah, maksudnya positif dan negatif untuk 50 Hz frequency. Kalau 60 Hz kita ada 120 signal positif dan negatif. So dia terlalu laju. Okay, so kita akan guna portion lah. This is on off. Okay, so okay. Okay, if the input voltage is connected to the load for n cycles and disconnect for m cycles, so n macam kawan-kawan cakap tadi on dan m adalah off, so the output load voltage is found by using this equation. On dan off kita ada equation lah. Okay, so this is final equation untuk dapatkan V out RMS. Okay, dia bergantung kepada m ditambah dengan n, number of cycle. Okay, note that K is called the duty cycle and the power factor and the output voltage varies with the square root of K. So power factor pun dia akan berubah, okay, bergantung kepada nilai K. So duty cycle. Okay, so dia macam kita bagi banyak and then kita tak fully utilize, power factor must be low. Okay, so this is the equation of the average of the output voltage RMS, and then this is the average. Okay, saya nak tanya kamu lah, do you clear with the concept of RMS dan average? Okay, untuk AC signal, kita ambil satu cycle positif dan negatif. So what will be the RMS voltage dan juga average voltage? Boleh saya tahu tak? Apa yang kamu faham tentang average?
Average total semua di semua sama rata tu lah.
Okay, total semua average lah. Tapi kalau RMS?
RMS ni sana rata.
Macam mana?
Sekejap. Saya pun tak tahu macam nak terang, tak faham.
Okay, kalau average, kalau AC signal, average dia adalah kosong. Okay, sebab apa? Bila we talk about average, so positive cycle will be considered as a positive value and negative cycle will be considered as a negative value. So bila kita combine, so kita averagekan dia, so dia sebenarnya close to kosong. But RMS dia berbeza. RMS adalah keluasan sahaja. Dia tak kisah keluasan tu di atas atau di bawah. Okay, kalau nak mudah lah, saya just nak tunjukkan kamu. Tapi itulah, maybe saya nak fokus dulu ke. Sekejap. Sikit simulation lah. Okay, signal yang tadi. Okay, so saya tengok V in sahaja. Okay, kalau saya tekan RMS, saya akan dapat 240. Tapi kalau saya tekan average, this is average, so value saya adalah close kepada kosong lah. Ni walaupun dia negatif, okay, sebab mungkin this signal is not apa namanya, dia tak symmetry, maksudnya ada beza sikit antara this one dengan this one. So tetapi dia akan close kepada kosong lah, negatif, which is milli, negatif 0.03. So sebenarnya bila kita panggil dia sebagai average, so this one will be considered as positive, this one will be considered as negative. So dia puratakan benda ni. Tapi kalau RMS dia lain. So RMS dia ambil keluasan. Okay, keluasan ni tambah keluasan. Same goes to this one. Okay, keluasan lah. Kalau contoh kita tengok average untuk the second one. So untuk second one dia ada. Okay, dia ada pada negative portion. So that's why the value is negative V out dia. Okay, sebab dia pada area negatif. Okay, so dia ada value plus 0.02. Boleh faham? Faham ke tak faham? RMS dan average.
Boleh lah, boleh lah.
Ya, okay, ambil dulu konsep tu.
Dapat gambaran.
Average dia consider positif dan negatif. Okay, so RMS tidak, keluasan saja. Okay, so this is by using by having inductive load lah. So dia ada extended. So the switching will not be turned on, okay, but will be extended. So dia akan extended sehingga beta. Okay, luckily under this condition, luckily because the alpha for the second thyristor is triggered just after the energy of the inductor is finished. So kamu nampak dia matilah dekat sini, and then this is alpha tambah pi, maksudnya the next cycle which is 32. So kamu nampak dia macam ni lah. So negatif, so dia akan ada signal. So this is I. So boleh faham tak this one? Okay, so ini kaedah kalau kita ada inductor lah. So kalau kita ada inductor kan dia ada extended sikit. Okay, so this is when we inject this one. Okay, boleh? Okay, sepatutnya dekat sini ada signal lah. Okay, ada signal sikit ni. Okay, sebab current dah akan flow ke sini pula. Dia masih boleh flow. Okay, I'm not sure why gambar ni. Okay, this is the signal lah switching kita. Okay, instead of kita bagi dia on saja, kita boleh pecahkan kepada PWM. Okay, beberapa portion. Kita chop dengan signal. Okay. Okay, so however a continuous gate pulse increase the switching loss of thyristor. So kalau kita continuous switching Hello? Are you still with me?
Yes, sir.
Tadi tiba-tiba dia disconnect pula. Okay, selalu macam tu lah. Dah ujung-ujung kelas dia start buat hal. Okay, so this is the equation lah. This is the final equation that we have for the load that consists of some inductive load. Okay, dia ada beta di sini. Okay, so dia ada beta di sini lah. Okay, kita akan pergi kepada 3 phase. Okay, so the unidirectional controllers which contain DC input current and higher harmonic content due to the asymmetrical nature of the output voltage waveform are not normally used in AC motor. So yang mana yang ada harmonic, so selalunya kita prevent untuk dia masuk kepada motor. Okay, sebab apa? Sebab dia akan menjadikan motor tu vibration. Okay, so dia akan ada higher harmonic, so kita prevent lah, not normally used in AC motor. So a 3-phase bidirectional control is commonly used. So bila 3-phase ni kita bagi terus dengan bidirectional supaya kita mengawal, sebab dia tak akan ada, untuk setiap phase tu kita akan dapat voltage yang konsisten. Okay, so this is when we have a bidirectional lah. So setiap switching kita menggunakan thyristor. Okay, this is how we get the signal lah, and this is how we give the signal for the switching. So mungkin kamu pernah belajar sebelum ni, masa bila kita nak on. Sebagai contoh, this is switch nombor 5, switch nombor 6, and then switch nombor 5, switch nombor 6 lagi, and then switch nombor 6, switch nombor 1. Sebab 6 masih lagi on, and then nombor 1. So dia bergantung kepada kita punya switching teknik. Okay, so researcher pun sekarang ni dia dah banyak do the research on this part. So ada multi-level inverter, okay, multi-level AC controller. So there are a lot of research have been done. So to improve the signal, in order to improve the accuracy for the output voltage. Okay, this is one way lah, yang basic. Okay, kita punya kaedah switching. So this is VAN lah. So kamu nampak dia keluasan. Okay, keluasan curve. Okay, so ini adalah kita punya signal bila kita inject pada 120. Okay, ini pada 60 darjah. Okay, I know that it's quite difficult for you to understand from this one because we are not simulating. Okay, sebab kalau kamu nak mudah, kamu kena buat dia punya simulation. Then you can adjust some angle so that you can see the difference before and after you change the switching angle. Okay, yang macam ni kita susah lah. 160 saya kena check 60 di mana. It's quite difficult for me to explain, but later if we have enough time, so I can show you based on the simulation. Okay, kaedah kita nak buat switch lah. Okay, salah switching kita akan dapat yang tak symmetry lah, kamu akan dapat bentuk yang berbeza. Okay, this is the equation lah. So bila kita ada alpha yang trigger between 0 to 60 and 60 to 90 and then 90 to 150, so they are quite different equation lah. Okay, so 648, 12, 16, 16, 24, 4, 16, 16. Okay, again because I'm not going to teach you on the power E punya concept, okay, we just utilize the final equation sahaja. Okay, so kita ambil equation yang akhir saja. Macam mana dia run benda ni? Maybe kamu kena buka balik nota power E. Okay, so this is also AC but the other concept yang kita mungkin namakan dengan nama yang berbeza. We call it a cycloconverter. Okay, so the AC voltage controller provide a variable output voltage, but the frequency of the output voltage is fixed. Okay, so in addition the harmonic content is high at the low AC voltage, high alpha, so dia akan ada high harmonic. Okay, so a variable output voltage at variable frequency can be obtained from a two-stage conversion. Okay, so dengan combinekan cycloconverter dengan AC, so kita akan dapat juga frekuensi yang berbeza. But basically when we talk about AC regulator, sebenarnya dia dah cover dua-dua lah. But in detail, dia pecahkan kepada portion of AC regulator just for voltage, cyclo is for frequency. Okay, first the fixed AC is converted to a variable DC. Okay, and then the variable DC is converted to a variable AC at the variable frequency. Sama macam kita punya inverter devices. So however, the cycloconverter can eliminate the need of one or more intermediate converter. So menggunakan cycloconverter tak perlu pakai rectifier. So they eliminate the use of the converter, the first one. Okay, so cycloconverter is a direct frequency changer that convert AC power at one frequency to AC power at another frequency by AC to AC conversion. Okay, so ini adalah untuk memfokuskan kepada frekuensi. Okay, cycloconverter are naturally commutated and the maximum output frequency is a fraction of the source frequency. Okay, kita akan main dengan fraction lah. Okay, separuh daripada source frequency, so 25. Okay, dia menggunakan fraction pecahan daripada kita punya frekuensi. Okay, so therefore cycloconverters are low speed AC motor drive in range up to 15 megawatt with frequency from 0 to 20. So kecil lah. So cycloconverter ni dia masih mengubah frekuensi but for low speed application. Okay, so this is the concept lah. Okay, kita ada P converter and N converter. Okay, so variable voltage, variable frequency converter output voltage. So ini yang kita combine lah. Okay, so kita combine, so kita ada dua-dua lah, voltage dan frekuensi yang kita dah ubah. Okay, so kita tengok dalam case ni dia wujudkan beberapa portion. Okay, kalau kita tengok this is the blue color. So ini adalah AC yang normal, and then di dalam satu AC normal kita mewujudkan lagi frekuensi. Okay, dalam case ni kita ada P converter on and N converter on. So dalam case ni dia akan on macam ni lah. Okay, so ini positive cycle, so ini negative cycle. Okay, so F out adalah Fs over N, so bergantung kepada portion. Okay, so N is the number of positive half cycle. Okay, so positive of half cycle. So you can see that F out ataupun frekuensi yang kita adjust adalah just a portion. Sebab dia divide by N, so dia akan jadi lebih kecil daripada supply frekuensi. Okay, so maybe nowadays pun kita sebenarnya dah boleh increase the frequency. Okay, ini macam yang fundamental lah, asas kepada to change the frequency level. Okay, and this is the equation to find the V out. Okay, so dia bergantung kepada kita punya alpha. Boleh? Boleh ke tak boleh? Do you have you learned this one before? Cycloconverter. Pernah belajar? Tak pernah belajar? Hello?
Yes, sir.
Okay, pernah belajar tak? Pernah dengar tak cycloconverter ni?
Cycloconverter. Rasa macam belum.
Hello? So, waktu kamu belajar AC to AC converter, so apa yang kamu belajar sebenarnya waktu power E? And I know that. Sebab bila kita melibatkan frekuensi, yes, frekuensi is important lah. So, nama lain yang komplit lah untuk the AC yang boleh ubah voltage dan frekuensi adalah cycloconverter. So, tak pernah dengar langsung cycloconverter ni. Okay, sebab dia di bawah AC regulator. Okay, so dia masih di bawah AC regulator lah. Okay. Okay, tak apa. Nanti saya, kalau ada masa, saya boleh cover balik Power E. Because saya pun dulu mengajar Power E. Yes, I also cover the cycloconverter. I'm not sure whether currently they are not focusing on cycloconverter. They just focus on yang voltage saja. I'm not sure. Okay, last time memang saya cover lah. So this is 3 phase, kita ada P and N converter. So dia sebenarnya adalah built-in lah. Dia ada nature of commutated. So dia sebenarnya sama macam rectifier juga, tapi kalau kita tengok dekat sini, cycloconverters are naturally commutated. So dia secara nature memang ada bersifat rectifier. Ada elemen tu, P converter and N converter. Okay, elemen tu masih ada lah, tapi kita mungkin nama dia lain. So by the nature, so dia memang boleh ubah kepada frekuensi yang berbeza kepada AC lah. Commutator macam saya cakap last time is a process to change from AC to DC. Okay, naturally commutated. Okay, so kita ada macam-macam lah. Ada 18 transistor I used to obtain a 3-phase full wave 3-phase converter. So sebab kita ada dekat sini kita ada P dan N, P dan N, P dan N. Dekat sini ada 3, so 3 kali 6 kita ada 18 transistor. Okay, so I think we have finished. Okay, I'm not sure whether you still understand whatever the information that I give you today, but hopefully you get something. Okay, sebab benda pergi agak laju disebabkan oleh this one already covered in Power E. Suppose that I'm not cover this one in detail lah, but if you still think that you want me to slightly cover lah, I'm not in detail lah. Okay, I can cover the detail on the cycloconverter as well as the AC regulator. Okay, but hopefully by this one, so kamu dah clear lah dengan kita punya nota. Okay, this is again kita bagi kredit lah kepada Universiti Tenaga Nasional. This note is also used by created by one of the lecturer in Unit 10. Okay. So ada apa-apa soalan sebelum saya stop? Tak ada juga. Ada soalan apa?
Tak ada sir. Tapi mungkin kalau buat example ke apa memang maybe banyak soalan lah.
Okay, kalau nak bagi example, nak bagi example, at this moment of time saya tak boleh bagi sesuatu yang bersambungan dengan motor. Okay, disebabkan oleh kalau saya bagi satu benda yang bersambungan dengan motor, kita belum lagi masuk kepada how to integrate lah between the drive and also the machine, the analysis lah especially. Okay, But if you still require me to give you some example, maybe I can focus on the question that focusing on power E. Maksud soalan tu memang pure power E punya soalan. Yang tu saya boleh bagi. Sebab kalau saya bagi yang berkaitan dengan mesin, so mesin punya analisis pun kita tak start lagi. Sepatutnya on the next chapter. Okay. Tetapi kalau perlu mungkin next week. Okay, next week kalau ikutkan kita punya timeline, suppose that we still in chapter number 2 next week. So bolehlah saya bagi 1 atau 2 sebelum saya proceed kepada the third chapter. Boleh?
Boleh sir.
So kalau tak ada apa-apa, so basically saya sebenarnya kena stop awal. Okay, disebabkan saya perlu hadir ke satu perjumpaan. So I will see you on next week. So next week again saya cuba dapatkan soalan lah. Hopefully on your part, untuk bahagian kamu dapatkan semula nota-nota power E lah. Itu je yang saya nak minta. Okay. So boleh saya tahu balik semula tak siapa yang ajar power E kamu semester selepas? Yang ajar E. Madam or siapa?
Madam Nazila.
Madam Nazila. Okay, saya cuba discuss dengan Madam Nazila lah. Okay, so supaya apa yang saya tanya itu maksudnya covered by Madam Azila. Okay, saya tak tanya something yang luar lah. Okay, so saya cuba discuss. Okay, so I think before that saya kena download your attendance list. Sorry for that. Minta maaf. Okay, 20 saja, tak apa. Okay, so I think I need to stop now. So thank you. Assalamualaikum.
Waalaikumsalam. Thank you sir.
Okay, welcome.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Thank you sir.
Okay, welcome.